Hold on, guys.
Can? Actually, I can't hear what you say, You
Unmute your mic on Zoom.
done, huh? So I have y equals to cosec inverse x, right? Cosec inverse x, right? So when I key in, I want to use the Desmos graphing calculator. So I change this one to x equals to cosec y. Then you can plot the graph. So you plot the graph. Sorry, not this one. You plot the graph, you look at this. Actually, if you enlarge it, right, you look at the dy dx. All the dy dx are negative, correct? The gradients are always negative. Okay, so this is the graph for y equals to cosec inverse x. So therefore, you look at your dy dx is always negative. So for this question, the first part, they say for x positive. For x greater than 0, you get dy dx equals to negative. Then when x is less than 0, so when x is less than 0, that means you replace your x with negative x. All right. Therefore, your dy dx is equal to 1 over x square root of x squared plus 1. Don't forget, your x here is negative. Therefore, your dy dx is still less than 0. Okay. So therefore, your dy dx change to 1 over x square root of x squared plus 1. You take away the negative that you have here. Take away the negative. All right. So that's how you solve question number 6. Right. So now we go back to the second derivative that I mentioned just now. Okay, this one is not in use anymore. I can just look at the d2y dx2. Okay, so let's look at the notes here. I cannot use open with PDF. I don't know why. Only today cannot. Right. You know what I'm talking about? So you look at this one here. To obtain an expression for d2y dx2 in the case where the relation between y and x is defined implicitly. So this is actually implicit differentiation. So for relations such as y cubed plus 3xy squared minus xy equals 11, it is often difficult or impossible to make y the subject of the formula. Such relationships between x and y are said to be implicit. And the process by which we differentiate such relations is called implicit differentiation. In this process, we simply differentiate term by term using the chain rule and product rule. So that means you need to
question 7 we don't need this, right?
Sorry? Sorry, Kelvin?
No.
What did you say?
No. I didn't mean to do that.
Sorry, sir. No.
You're not talking to me, is it?
No. Sorry.
Okay. So you have to look at the chain rule here. You have to make use of the chain rule here later. All right. So now we look at how do we do this one. So we look at the examples. So we start with question number 7. All right. Okay, question number 7 here is not implicit. We look at some implicit examples first. Look at the past year question. Right. Probably we can look at question number 45. Let's look at question 45. Or maybe 44. Okay, we look at 44 lah. 44. Okay, question number 44. Question 44, they ask for show that there is no point of the curve at which dy dx is equal to 0 for the given implicit equation. So question 44. Okay, I refer to my own notes. Question 44. Question 44, you have the implicit equation x cubed plus xy squared. All right. Okay, 44. So you have x cubed plus xy squared minus y cubed is equal to 3. Okay, so first part, they ask you to show that there is no point of the curve at which dy dx equals to 0. So obviously you need to differentiate the equation star. Okay, let's say I call this equation star. So you have to differentiate star with respect to x. So you have to get the first term, 3x squared. Now the second term, xy squared, you have to differentiate using implicit differentiation chain rule. This one is product rule, sorry. So you have to copy the x, differentiate the y squared. Therefore, you have 2y dy dx. Okay. Then after that, you copy the y squared. Then you differentiate the x, you get 1. Continue. Differentiate the negative y cubed. That would give you negative 3y squared dy dx. And you set this whole thing equals to the differentiation of 3 is equal to 0. So this is the first time you differentiate the equation implicitly. However, they ask you to show that there is no point of the curve at which dy dx equals to 0. So you assume that dy dx equals to 0, assuming dy dx equals to 0. Then you prove that your assumption is wrong. Therefore, dy dx cannot be 0. All right. So you assume dy dx equals to 0. Therefore, you have the balance. The balance is 3x squared followed by positive y squared is equal to 0. Right. You get the equation like this. 3x squared plus y squared equals to 0. You will only have one answer. What is the answer? This is equal to 0 if and only if your x is equal to y is equal to 0. Right? That is the only answer. So therefore, when x is equal to y is equal to 0 is the only answer. Now I sub x equals to y equals to 0 into the equation star. You put it back into star. Okay. So when you put it back into star, so you have left hand side is equal to 0 cubed plus x. Sorry, x is equal to 0 as well. So you have 0, 0 minus 0. So this is equal to 0. And this is not equal to the right hand side. So there is a contradiction. So you make a conclusion. There is a contradiction. So this is the term that you can use. So therefore, there is no point, all right, of the curve. There's no point of the curve at which your dy dx is equal to 0. Okay, so this is the contradiction for part A. Then after that, I'm going to use this cyan box to solve for part B. I'm going to use this one. So let's say I call this equation hash. Okay, so for part B, find the values of dy dx and d2y dx2 at the point 1, negative 1. So you can continue by differentiating. So B, differentiating hash, equation hash with respect to x again. Right, for this part, you have to be careful because you see you have 3x squared, you have positive 2xy dy dx plus y squared, then minus 3y squared dy dx. All right, so in this case, I will look at, oh, you got the dy dx, the common term. You got this common term here. So probably I can just simplify as usual. I can take out the dy dx first lah. So I don't call this equation star. Maybe I don't call this equation star. So I cancel this one. Don't want the star here. Okay. So I don't differentiate first. So I have the equation. I write down the equation from part 1. From part A. From A, I have 3x squared followed by positive y squared followed by dy dx. You factorize, then you check what are the terms inside. So you have 2xy and then minus 3y squared, and this is equal to 0. So now you differentiate this one. Okay, so you differentiate this one. You call this equation hash. You call this equation hash. Right? Only you say differentiate equation hash with respect to x. So you have the first term, 6x squared. Then you have the second term, you have 2y dy dx. Only this one is a bit challenging. This one in the cyan box. So you need to differentiate. That becomes sorry, how do I differentiate what?
Isn't it 6x?
Hey, sorry. Yeah, 6x, not square. Right. Thank you. So I have 6x plus 2y dy dx, followed by, now I have to differentiate this. So to differentiate this one, I can differentiate the dy dx and obtain d2y dx to copy the bracket. So I have 2xy minus 3y squared bracket. Then after that, I copy the dy dx followed by the differentiation of the bracket. So the differentiation of the bracket means the first term you have 2xy, you have to use product rule again. So you have 2x and differentiate the y, dy dx plus 2y. Differentiate the x, you get 1. Then differentiate the 3y squared, you have minus 6y dy dx. So this one becomes a bit more complicated. And this is equal to 0. Okay. Now, you don't have to simplify because they say find the values of dy dx and d2y dx too. So let's say now you call this equation star. So you must first determine the value of dy dx at the point 1, -1. So you sub x equals to 1, y equals to -1 into star. So you go back to the first part, the equation of star. Equation of star is, sorry, not star. Equation of hash. Equation hash. Okay. Equation hash. So equation hash is 3 times 1 squared plus -1 squared, because that is y squared, then plus the dy dx is the term you are looking for. So dy dx, and then open bracket, you have 2 times 1 times -1, so -2, right? Then minus 3, because y squared means 1. So -2 minus 3, and this is equal to 0. So you simplify this one, you get 5 dy dx is equal to, so you simplify the left hand side, you have 3 plus 1, so you get 4. Therefore, dy dx equals to 4/5. That is the first answer. So continue. Then you sub x equals to 1, y equals to -1, and dy dx equals to 4/5 into equation star. Okay, so the equation star. So ready, you put in the values. You have 6 times 1. 6 times 1 is just 6 lah. No need to write so many. So you have 6. Then you have 2y. 2 times -1 means -2. Then dy dx is 4/5. So it's 4/5. Then after that, put the d2y dx to d2y dx to. Then you calculate the terms in the bracket. You have 2 times x times y. So 2 times 1 times -1. You get -2 minus 3. Right. Then continue. Plus dy dx was 4/5. It was found as 4/5 just now. Then open bracket. You have 2 times 1 times dy dx. So 2 times 1 is 2. Dy dx is 4/5. So you get 8/5. Then after that, 2 times y is -2. Then minus 6 times y. So it's positive 6 times 4/5. And this is equal to 0. So can someone please simplify this one? I think you get 6 times 8/5. So dot. I leave it to you. You simplify now. d2y dx2 is equal to. I think the answer is given at the bottom, right? So d2y dx2 after you simplify, it should be 198/125. Okay. So you should be able to get these answers. dy dx equals to 4/5. d2y dx2 is equal to 198/125. Correct me if I'm wrong.
It's correct, right?
Okay. Okay, I will move on to question number 46. Okay, I have shown you majority. I have shown you most of the steps here already. Okay, so 44, the answer is here. Then we can go to question 46. Do one more. You see, the process is a bit more complicated already, you know. So you must be careful when you are doing this part here in the blue box. You must be extra careful with this blue box here, blue box. And this blue box, generally the most difficult part is the cyan box. For this cyan box, you need to be very careful. This cyan box here, which then give you the expression in this form. This is the cyan box. This is the part that will confuse a lot of people, and majority cannot get the answer. Usually is because of this one. Usually, all right. So you must be careful. So I will do one more question, number 46. So 46. This is question in November 2006. Now the curve C has equation y equals to x squared plus lambda lambda sine multiplies by a sine of x plus y. Okay, so they told you lambda is a constant and it passes through the point a 1/4 pi, 1/4 pi. So it passes through this point a pi/4, pi/4. Right. This is the given information. Show that C has no tangent which is parallel to the y-axis. So if they say tangent parallel to the y-axis, what does that mean? This implies that your dy dx should be infinity. So if your dy dx is infinity, that means the denominator must be equal to 0. So that means your dy dx must be a rational function and the denominator must be equal to 0. That is the meaning. The tangent is parallel to the y-axis. However, for this question, they say C has no tangent which is parallel to the y-axis. That means the denominator cannot be 0. All right. So let's look at what are you going to get for your dy dx. Then later on, you have to prove that the d2y dx2 is equal to the given function. Question 46. You refer to your own handout. So question 46, we start with differentiating the equation star. So let's say I call this equation star. So you differentiate equation star with respect to x. So I have dy dx is equal to, I have 2x plus, keep the constant lambda, followed by sine x plus y. So you have to differentiate sine. So you get cos x plus y, then use the chain rule. You are supposed to differentiate all the terms in the bracket, which is x plus y. So therefore, we move on with the chain rule. So 2x plus lambda. Now this one changed to cos already, x plus y. Then you have d dx x plus y. d dx x plus y is just 1 plus dy dx. So this is quite straightforward. Okay. And now they said you have to find dy dx in terms of x and also y. Okay, you have to find dy dx in terms of x and also y. So that means you will need to expand. So you have 2x plus lambda cos x plus y, close bracket. Then the other one is plus lambda cos x plus y with dy dx. So move this cyan box over. So you move this cyan box over to the other side. So therefore, you get 1 plus lambda cos x plus y. So you can now factorize the dy dx. And this is equal to the right hand side. So you just copy 2x plus lambda cos x plus y. All right. So therefore, your dy dx is in the form 2x plus lambda cos x plus y on top. Then the bottom is 1 plus lambda cos x plus y at the bottom. Okay. Now, the question says, show that C has no tangent which is parallel to the y-axis. So what are you supposed to do? You are supposed to make sure that the dy dx is infinity. So dy dx is infinity if and only if the bottom part is equal to 0. So you need to argue using this denominator. Right? So what happened now is you set 1 plus lambda cos x plus y equal to 0. So you solve this one, you will get cos x plus y is equal to negative 1 over lambda.
Sorry, sir.
Yes. Yeah.
Isn't it the denominator is 1 minus lambda cos x plus y?
Okay. Why?
Because isn't it at the right hand side on the top is plus lambda cos x plus y divided by dx. If you move to left, isn't it become negative?
Oh, yes. Sorry. So you have One of the sign here is wrong. Let me check. This one is wrong, right? So this one should not be plus, it should be minus. So if this is minus, means this part is also minus lah. I think I erase lah. Otherwise it becomes messy. So it should becomes 1 minus lambda cos x plus y. So this part also becomes 1 minus lambda. Okay, cos x plus y equals to 0. Then cos x plus y is equal to negative 1 over lambda. Now you get this equation. All right. The problem is you don't know what is lambda. Is there a way to find lambda? Now you go back to the given equation. Y is equal to x squared plus lambda sine x plus y. Is there a way to find lambda? Given that this curve passes through the point A with coordinates quarter pi, quarter pi.
Sub x and y with the
Into equation star. Okay, so now I'm going to check with this one. Yeah, so now to find lambda,
So shouldn't it be 1 over lambda now?
1 over lambda. Yes, take away the negative. Okay,
Yeah.
so to find lambda, let x equals to y equals to pi over 4 in equation star, right? So equation star, you have x squared. So you have pi over 4. Okay, never mind. I use pi over 4 in the bracket square. Then you have plus lambda sine pi over 4 plus pi over 4. And this is equal to pi over 4. So therefore, you know that this part, the cyan box is sine pi over 2. And this will give you the value 1. So therefore, you have lambda equals to pi over 4 plus lambda, minus pi over 4 in the bracket squared. Okay. So in this case, you can see that this is equal to a value pi over 4. And this is 1 minus pi over 4. Hey, no use. Sorry. What is this value? Pi over 4 minus pi over 4 squared. Give me at least 5 significant figures, please. One, 6, 8, 5, 5, up to 5, 6 fig, yeah? Right, now you have enough evidence to reject the equation that you get in, okay, let's say I call this equation star star. Equation star star. Now you can reject already. Give me a reason why you can reject.
1 over value smaller than 1 will bigger than 1, and then cos cannot be bigger than 1.
Yes, so you have to argue this way. Since 1 over lambda means what in this case? So the reciprocal of 0.16855 is what? Give me the value. 1 divided by 0.
5.933.
5.933. So clearly this is greater than 1, right? So when this is greater than 1, therefore equation star star has no real solution. So when equation star star has no real solution, what does that mean? That means our original assumption of d 1 minus lambda cos x plus y equals to 0 is wrong. Okay, so therefore dy dx is never infinity, and therefore what we want to prove already? Sorry, I forgot. We have to prove that C has no tangent which is parallel to the y-axis. So it just said, just copy. Therefore, C has no tangent, which is parallel to the y-axis. Okay, so that's how you argue. You see, I always choose this kind of questions to discuss with you. I don't want to discuss with you the questions where they ask you, okay, find the value of dy dx and also d2y dx2, because I'm afraid you don't know how to argue, all right? So I show you some of the ways here to explain. Of course, you can use your own explanation as long as you can show there is a contradiction, or you can show that the equation cannot be solved, or you can say that the equation has no real solution. Then you have achieved.
Okay. Oh. Number.
Okay, can you hear me? Someone is calling me. I don't know who is that. So C has no tangent which is parallel to the y-axis. Okay, done. Now we move on to the second part. May I know how much time left? Can someone please check for me?
6 minutes.
Okay, 6 minutes. I think I can complete the second part and then leave it to you. So for the second part, d2y dx2 means you have to differentiate again. So you differentiate, right? You don't go and use the dy dx form here. Okay, don't go and use this one. Don't use this one. Don't use this, the red box. No. Okay, you use the previous one. You use the previous one means this is the okay form. See, you use this one to get the d2y dx2. Okay, so you have b. So you differentiate again. Differentiate. Maybe you give it a name. Let's say this one is hash. So differentiate hash with respect to x. So therefore you have d2y dx2. So that's the first term, d2y dx2. Then this is equal to, you have 2x, you differentiate, you get 2. So you have 2 plus, then you have lambda cos x plus y. Lambda cos x plus y. I think you use this form. dy dx, this form, better. Not this one, this one. Okay, so lambda cos x plus y means you copy lambda cos x plus y first. Lambda cos x plus y, copy. Then you differentiate whatever inside the square bracket. So you differentiate 1, you get 0. Differentiate dy dx, you get d2y dx2. So you get d2y dx2. Then after that, you copy the 1 plus dy dx. Then you differentiate lambda cos x plus y. So lambda is forever there. So lambda is forever there. Differentiate cos becomes negative. So you change this one to negative lambda 1 plus dy dx. Then this one becomes sine x plus y. Then you differentiate the x plus y again. You will get 1 plus dy dx, right? So this 1 plus dy dx, you got multiply the two of them. Hence, you can simplify this to 2 plus lambda cos x plus y, followed by d2y dx2, then minus lambda, then you have 1 plus dy dx in the bracket, square, followed by sine x plus y. So you use this one to find the value of d2y dx2 at a, all right? So the rest is just substitution. So you just need to substitute, okay? So let x equals to pi over 4 equals to y in first part. First part result, you have the dy dx, right? So you get the dy dx first. Okay, so dy dx. And they want the value in terms of lambda. So you don't put lambda first, yeah? You keep your answer in terms of lambda. So dy dx is equal to 2x lambda cos x plus y, you get 0. So you have in part 1 in equation hash. So you have dy dx equals to dy dx is equal to, then you have 2 times x, so pi over 2. Pi over 2, followed by lambda times cos. Lambda times cos pi over 2. Oh, that is fantastic. 0 straight away. So you get dy dx equals to pi over 2 only. Okay. Then after that, you let x equals to y equals to pi over 4. And dy dx equals to pi over 2 in this equation. So let's say I call this equation hash hash, double hash, in hash hash. Then you will get the answer. So you have d2y dx2, d2y dx2 equals to 2 plus lambda. So you have 2 plus lambda. Keep your answer in lambda first. Oh, this is lambda cos. Fantastic. You get 0. So you have 2 plus 0 and then minus lambda followed by 1 plus dy dx is pi over 2. So you have 1 plus pi over 2 squared. And then sine pi over 2 is 1. So basically you have 2 minus lambda, then 1 plus pi over 2 squared, right? So you simplify further, put in the value of lambda, and now they want the exact value of lambda. So you can simplify further. The lambda that you obtained just now was pi over 4 minus pi over 4 squared. So in other words, is pi over 4 bracket 1 plus pi over 4. A minus pi over 4. Sorry. Minus pi over 4 plus pi over 4 in the bracket squared. I think you have this one. Then this one you have 1 plus pi over 2 squared means you have 2 plus pi over 2 in the bracket squared. I think you can simplify already. Okay, because you can see the form already. So your job is to simplify this one. So maybe you get 2 minus, because the final answer they want minus, yeah. So I factorize minus. So I have pi over 4 factorize. Then I get 1 minus pi over 4. Then this one is 1 over 4. Then this is 2 plus pi squared.